Let's look at a new function. K of x is equal to x squared plus 3. So we want to evaluate k by putting in a minus 4. We put it in where the x used to be. K of x, there's the x. Now I want k of a minus 4. So I'm going to take my a minus 4, square it, and add 3. So if we take our a minus 4 and want to square that, we should write it twice because we cannot distribute exponents. Do not try to distribute exponents when there's adding or subtracting in the inside of parentheses. When I multiply this out, I get a squared minus 8a plus 16 plus 3 more, which is a squared minus 8a plus 19. So when I evaluate the function with a minus 4, I get a squared minus 8a plus 18. Oh look, we're going to do that difference quotient thing again. In k, we're going to stick an x plus h, and then we're going to just leave the x in there, and we're going to subtract those two expressions. So we'll take our first grouping, replacing x with x plus h, square that, add 3, and then we will subtract the function evaluated at x, which is x squared plus 3, and we'll divide by h. Now I left a gap so that you would notice that this x plus h is what has to go in where the x used to be. So here was x, now it's x plus h. Okay, in order to do this problem we need to clear parentheses. So we need to do this x plus h squared, which is multiplying it to itself, x plus h, and then adding 3, and then subtracting x squared, and then subtracting 3, and dividing all of that by h. So if you clear the parentheses here, you'll get x squared plus 2xh plus h squared plus 3 minus x squared minus 3, which is all divided by h. Combining like terms, we can add a positive x squared to a negative x squared. That'll add to 0. A positive 3 added to a negative 3. That'll add to 0. And so we're just left with this expression here. We can factor out an h because it's common. And we'll have a 2x plus h left to the inside. And we're trying to divide that by h. So if we reduce one last time, h goes into h once. Our final answer is 2x plus h.